Alrighty, so welcome to the first official Structural MD podcast. I am your host, James Hilligus. So, I don't have an intro for this show, and hopefully in the future I will get one. Also, I don't have a quote-unquote official recording studio, so I do my best to record these on off hours, when people aren't around. So I try to eliminate as much door closure and background noise as possible, but please excuse any, noises if there are. I typically will try to do this when people aren't home, so they don't, don't have the background noises and it's not annoying and it's a little bit more professional. As the podcast advances, maybe I will look into getting a more, soundproof room or renting a sound room, a recording studio to record a couple episodes and then release them so it's a little bit more professional than me with a microphone and my laptop. But nonetheless, here to deliver the information. So in the first official episode, I'm going to talk about America Makes. Basically, again, this is the first one. I'm just going to cover 3D printing, and in the future, I will add in the other topics that I discussed in the very, very, very first. Now, this numbering scheme of being 00 or 000 for the first episode is really going to mess with me because technically this is the first episode, but if I recorded one, you see that what I'm saying. It's going to get confusing, and I'm probably going to mess that up many times. So anyway, without further ado, let's just jump right into it. No need to waste time. So again, we're going to cover the who, what, where, when, why, and how of America Makes. So where is America Makes located? Some may guess Washington, D.C., L.A., San Francisco, New York, a big metropolitan area, or perhaps, the capital of the United States. A logical guess. I applaud you for the effort, but really, America Makes is located in Youngstown, Ohio. Now, many of you have probably heard of Akron, Ohio, the home of LeBron James and Steph Curry, and Cleveland and Cincinnati and Columbus, the big areas, but Youngstown, Ohio, maybe if you're around in the mid-1900s, you would have heard of Youngstown, Ohio. But now, does anyone really know where Youngstown, Ohio comes from? The last great things to come out of that area of Ohio was Maurice Clarett, back for Ohio State in 2002. Obviously, I'm from Ohio, so that's why I know that. Some of you may not. But nonetheless, America Makes is located in Youngstown, Ohio. So if you were to look on a map, it's roughly halfway between Cleveland and Pittsburgh, PA. It's about 45 minutes-ish, give or take, from each. It's east of Cleveland and west of Pittsburgh, if that helps you out a little bit. And it's part of the iconic Rust Belt. And so the Rust Belt is typically categorized as, northeastern, midwestern cities with declining industry, and they have aging factories and a falling population. Basically, they were the old steel-producing cities like Pittsburgh. So a brief history on Youngstown just for the sake of, maybe when you get on Jeopardy someday and you need to answer a question, or wait, you propose a question on Jeopardy, I think. You say, what is? So they would say, it's located halfway between Cleveland and Pittsburgh, PA. And you would be like, it is Youngstown, Ohio. Or what is Youngstown, Ohio? Anyway, getting on a tangent there. So it was founded by John Young in 1797, and he incorporated it in 1802. He purchased the roughly 15,500 acres from the Connecticut Land Company for 16 G's. That's like a drop in the bucket. Today, that would be well over hundreds of millions of dollars. I try to do one of those online conversion calculators, that accounts for inflation and the cost of a dollar and etc. However, it came out to so many zeros. One of them didn't go past 1904. So it was rough to find one that went all the way back to 1797. Anyway, in the late 1800s, the first steel mills were built in the city. And then by the 1920s, it was a second to Pittsburgh in steel production. And again, like most steel towns, it experienced a lot of peaks and valleys, booms and busts. So with World War I, steel going up, needed for the tanks and all the artillery, the armor and things of that nature for the military. The Great Depression hit in the 1920s, 1930s, dropped down. Then World War II comes around and it went back up. And then steel started to become imported from places that were cheaper, overseas, China, etc. And now it's pretty much a declining industry, a lot of empty smokestacks, and it's an unfortunate scene. But hopefully with 3D printing and the additive manufacturing movement and what America Makes is trying to do, hopefully that'll change for the community of Youngstown. Alrighty, so now that you know a little bit about where America Makes is located in Youngstown, Ohio, you're happy you can visit it. It's kind of a museum. You can set up appointments, as far as I know, to take a tour. By the way, don't tell them that this kid James with a podcast, who's a college student, told you he said you could take a tour, because that's not how it works. Just from what I've read, you're able to take a tour there if you kind of set things up and visit, and you can learn. And it's a nice place. I've been there once before for a meeting. So let's jump into who America Makes is. Who are they, and when was it founded? I'll touch more on the history of 3D printing in later episodes, but 3D printing has been around for a lot longer than when America Makes has existed. Most would think that they kind of came out around the same time, and they came out about almost 30 years apart. 3D printing coming out, and then 30 years later, America Makes was created. So America Makes, I guess the longer quote-unquote official name, is the National Additive Manufacturing Innovation Institute. And that's kind of like how 3D printing is the sexier term for additive manufacturing. America Makes is the sexier term for that really long name I just gave you. It sounds cooler to say America Makes than the National Additive Manufacturing Innovation Institute. One of those disclaimers, you talk really fast. So currently, last I checked, they're managing about $87 million in additive manufacturing research and development, and that's anywhere from just starting to a concept, an idea like, ooh, this would be cool to research, or to a completed project. It's all on that spectrum, if you will. So it was established in 2012, and it consists of about 200 members. These members can be academic, for example, like a university. They can be industry, like John Deere, Boeing, Caterpillar, big name manufacturing companies. They can be nonprofits. I believe ASTM is a nonprofit, or they can be government. NASA, the Department of Defense, and things of that nature. One of the really cool things that they're doing is they're supporting innovation needed for life on Mars. And one of the interesting things is, well, if we're going to inhabit Mars, for example, obviously there's going to be a lot of construction. But with traditional construction, that's a lot of equipment and material, and obviously sending it, God knows, millions of miles or thousands of miles to Mars. I don't know the exact distance. I just know it's far away. Well, that's kind of expensive, and you really want to avoid that if you can. So possibly with 3D printing, they have some ways around it, and I'll touch on that technology in a future episode. It's called contour crafting. And that's a really interesting technology created by a professor at USC, and I will touch on that. But that's really a big goal to have, supporting innovation needed for life on Mars. I mean, that's crazy to think about. 300 years ago, roughly-ish, I know it's a bit of a little overestimate, when the country was founded, the United States, I mean, we were just worried about conquering what was west of the Mississippi. A little over 200, 300 years later, we're trying to conquer a whole nother planet. That to me is just mind-blowing. I'm a nerd. Come on. So anyway, a big achievement for America Makes was they established their first satellite office in El Paso, Texas in August of 2015. Obviously, that's their goal, to be first of many. So why did America Makes pick El Paso, Texas, of all places? Well, it turns out the University of Texas at El Paso, and I didn't realize that the University of Texas has different branches. The main one is at Austin, and then they have a branch at El Paso, and they have some other ones. And I didn't know that. But anyway, I guess UTEP is the abbreviation, UTEP. They have a renowned Center for 3D Innovation. It's called the WMKEC. I could be pronouncing that wrong. Center for 3D Innovation. UTEP spends roughly $80 million annual on research. That's a lot of money. Their research center was founded in 2000, so in between the discovery, if you will, of 3D printing and the creation of America Makes, pretty much right in the middle. It's a research facility housed about 50 people, includes staff, students, faculty, and researchers. They do multiple disciplinary research. They focus on, again, using the additive manufacturing for the development of technologies both in manufacturing and multiple disciplines. They have state-of-the-art equipment. They have 15-plus years of experience, obviously being founded in 2000. It's 13,000 square foot facility. You don't just have to be local industry to use it. You don't just have to be located in El Paso. You can be located around the country in the United States. Heck, you can be international. They focus primarily on a couple technologies, material extrusion, vat photo polymerization. How about that for a Scrabble word? And powder bed fusion. So some of the work that they typically do, this includes, 3D printed electronics, airplanes, satellite components, human augmentation, biomedical implants, and future energy systems. Now, I couldn't get a whole lot of I couldn't get a whole lot of information in regards to the projects. Obviously, a lot of things are kind of patented and protected. They're typically for somebody, so they don't, and they're typically a new discovery, if you will, so they're not just willy-nilly passing things out. But the interesting thing about America Makes, and let me touch on that. So there's 3 membership categories. There's silver, what they call supporting. There's gold, what they call full. And there's platinum, what they call lead. Now, each of the categories obviously has a different initiation fee, going from $15,000 to $50,000 to $200,000. Now, the interesting thing is, so what do you gain with this? First, let me touch on that. What do you gain? Well, you gain valuable access to IP. Basically, if someone has something patented, so say John Deere has something patented, and you want to look at it as Caterpillar, you can through America Makes. However, if you were John Deere and Caterpillar out in, let's say, the business world or the competition world, that wouldn't happen. John Deere wouldn't be like, oh, hey, Caterpillar, here's our patented technology for whatever, this hydraulic line, let's say. So you get access to that valuable IP created on 3D printing. There's technical presentations. There's project calls on the various projects they have. I will put a link in the show notes to their project page with all the projects they are doing at America Makes. And you also get access to the Innovation Factory where they do have all of the 3D printers. So it's kind of like a printing service bureau, if you will. So the interesting thing about the fees, let me touch on that. The interesting thing with the fees are, let's say you wanted to do gold. It's right in the middle. It's $50,000. You're a startup. You don't have that $50,000 as typical with most startups. You don't have really any money. You're just barely getting by to keep the lights on in your building. The fees can either be paid in cash outright, 50 G's thrown on the table, or you can do it through your contribution of services and products. You could loan your printer to research and printing stuff for research. You can loan your services or your brain power, I guess is the best way to put that, and say, I'm not exactly sure how it works inside of America Makes. I haven't looked into joining myself. I don't have anything that I can offer to them. So I'm not sure if it's I'm not sure how they calculate your services. Are you $200 an hour and you work for 8 hours and that kind of thing. So I'm not sure exactly how that works. What is America Makes now? What is it? We know kind of how it was founded, where it's located, but what's really their goal? We know one of the goals is to establish, life in a community on Mars, if you will. Kind of crazy. So their main goals are to accelerate additive manufacturing. Obviously, all of it is going to involve additive manufacturing and the different processes and how it can help. They want to strengthen that ecosystem within the country. Obviously, because it's located in the U.S., you could be an international user. They want to keep America or the United States competitive with other manufacturing countries like Germany and China and Japan. Keep us on pace. So as a country, the United States doesn't fall behind. In your country, they may have something similar. Again, I can't touch on that. They want to promote the collaboration innovation. Like I said, it's a consortium of 200 companies. It's growing. That number, whenever you listen to this podcast, that could be, too low now. It could be up to 220, 250, and growing. So again, the collaboration. You have access to all of that IP. The project calls. Typically, a project is multiple people, and it's maybe multiple companies, multiple government agencies, multiple universities. It's a really unique and interesting thing that is going on at America Makes. It's truly remarkable. Again, they want to help the industry adapt the disruptive changes of additive manufacturing. And really the interesting thing is technology has become really disruptive. So a lot of people have heard of technologies like Uber or Airbnb and how much those are disrupting the the taxi and the hotel industry. Technology is being really disruptive. And basically America Makes is like, well, let's jump on this technology train. Let's learn how to use it so we as a country, or you guys as companies, don't get ran over by it. Because maybe the taxi companies were able to adapt to Uber in some way, and then maybe the taxi companies made their own app, or they somehow worked out an agreement with Uber where their taxis would be the cars that showed up and you push the button kind of deal. Instead, the taxi companies sort of stood in the tracks of Uber and didn't, I don't want to say denied it in a sense, but really didn't acknowledge its presence, and then just kind of got ran over and flattened by it, kind of like Netflix and Blockbuster. Nobody says Blockbuster hit anymore. It's all about like this Netflix and chill or stuff like that. It's about adapting technology and getting into it and jumping on board that train, because the train's coming down the tracks. I mean, a lot of the things we talk about today didn't exist 10 years ago, and it's crazy to think about. And again, they want to build the additive manufacturing workforce of tomorrow. Again, it relates back to adopting that technology, jumping on board that train, staying competitive with all of the other countries in the world, and even outpacing other companies. There's only 200 companies that are using the technology or using America Makes. There's a lot of manufacturing companies that could take advantage of it. A lot. I mean, in Ohio alone, there's a lot of manufacturing companies, and not all of them are in there. So taking advantage of it gives them a head start, a jump start for when the technology becomes more mainstream. Because in the Wohlers report, the last one I read was, I believe, 2015. I don't believe I've read the 2016 one yet, if it's been released. The manufacturing industry is trillions of dollars, and additive manufacturing industry is only in the billions. So it's still a small fraction of where it has the potential to grow to. So how does America Makes go about this work of promoting additive manufacturing, of growing its use in industry, of making companies in the United States more competitive? So they basically broke it down into 3 steps. There's identifying the challenge. There's the next step of escalating the investment, and then the final one of doing some project models. And they have some really good graphics on America Makes website. Again, I'll link those exact links in the show notes, which could be found at structural-md.com/P001. In case you're driving in the car or whatever, I don't want you to have to stop and write that down. It's pretty simple to remember, so you can keep on going with your life. So that's basically how they break it down. And I can't click on projects because I'm not a member. One day I would love to be a member, and that's definitely on the list of goals to achieve for Structural MD, is to become a part of America Makes. I believe it's a great cause, and it can help out a lot of companies. And maybe for your company, it could be something to look into and joining, even if it's just a simple $15,000. I'm sure companies spend that much money on other sources that could be used to growing their business for the future, to keep them on that technology train that we touched about. So identifying the challenges. So they want to identify a significant and a meaningful challenge that could accelerate advancements in additive manufacturing. So what's some of the challenges? Well, some of the challenges, that are, if a part is made in the traditional manufacturing methods, of maybe a mold or CNC or something like that, maybe it's a consortium of multiple sub-assemblies, and they'd like to make it one complete assembly. Well, that's a challenge that you can apply 3D printings towards. If that challenge is meaningful, and a lot of people are like, holy, that's really cool, like we'd love to do that, you bring it to the next step, so you escalate some investment into it. Basically, it's kind of like growing a company, if you will. You're an individual, you see a problem, you have a potential solution, you talk to people, and they're like, this is kind of interesting. Then maybe you talk to some investors, and they put money in your idea, and then you start working on creating your product or the solution that you thought of, and that's your project model. And that's kind of a similar process to what they do at America Makes. So once they identify a challenge that's meaningful, they explore the problem, and then they coordinate and collaborate to identify, focus, and accelerate solutions that drive the research to the marketplace faster. Again, one of the advantages of technology, or of 3D printing technology, is the fact that it can greatly reduce the time to market. It's a lot quicker, prototyping's a lot better, and I'll definitely hit on that more in later podcasts. So the project model, it's kind of the last step of the process. And to kind of motivate people, a lot of people like to be incentivized. That's why commission-based pays work, because people are incentivized. And so to incentivize people, they include, project calls, they'll do challenges, they'll crowdsource different projects, and each approach kind of attracts different people. And bringing in different people always have different viewpoints, which, leads to a better, solution to the problem. If you have people with multiple different viewpoints, different experiences, and you can come to, a better solution. Because, for example, let's say my background being civil engineering, if you just are an engineer and you strictly design in a box, in your office and at the computer, and you never go and visit the site, or you never go and talk to the contractor who would perform the work and things of that nature, well, you're really doing a disservice to your client, solving the problem for your client by not going out and talking and investigating and motivating and looking at things. Because as an engineer, you can draw whatever you want on a computer, but at the end of the day, someone's got to figure out how to build that. And constructability in civil engineering and in traditional methods of manufacturing is definitely a concern when creating a design. Can we even create what you just drew in the computer? Is that possible? And that's one of the reasons why a design build process is becoming so unique in construction, because it's a different project model, if you will. It has different incentives. People can work together in different ways. And they've really had a lot of success with it, and that's something they're doing at America Makes. So how does America Makes go about that? So they've identified a project, they got some funding, people are interested. They basically broke down the 4 different types of projects into 4 different focus areas, or what they defined as swim lanes. So there's a design swim lane, a process swim lane, a materials swim lane, and a value chain swim lane. So there's a bunch of different projects, and they broke them out into the different areas. So a good analogy would be like football. So football, there's the offense, the defense, and the special teams. And you break down the plays into different categories like that. And it's the same idea. There's the overarching goal of, getting 3D printing into industry and into the economy and keeping us competitive. But there's a bunch of different subsets of that. There's a bunch of different processes, swim lanes, if you will, within manufacturing, regardless of what you're manufacturing. You have to design it, and then you make an assembly line or a process to fabricate it. And then you need to get the materials, whatever materials you're going to use for that process that you designed. And then there's also the value chain. So you have, your tiered suppliers. And again, I'm not an expert on manufacturing, how the whole process works. I'm a civil engineer, but you guys understand from that standpoint how that all goes down. The first swim lane is design. So before any of this other stuff matters, before you get to the process and the value chain and the materials you're going to use, you have to create a design. And one of the things with the design swim lane is they want to push some technological advancements in new and novel ways to design methods and tools that are a cultural change, because really it's a paradigm shift, from the traditional methods of manufacturing. You were really limited. You had to think within a box, if you will, because there's only so much potential or so much capability in the traditional methods of manufacturing. So you're trying to break out of those with, computer-aided design and computer-aided manufacturing, or computer-aided engineering, or product lifecycle management. Those originally were developed with the traditional methods of manufacturing because 3D printing wasn't around. But now that 3D printing is around, those same programs and methods and design processes, if you will, are no longer worthy or have the credit or merit to hold up to what can be done today. For example, I saw a picture recently of something that was 3D printed, and it wasn't really 3D printed for any use, if you will, other than to show its potential. It was a ball printed inside of a ball. And the interesting thing was both balls were separate. There's no way possible with traditional manufacturing methods that you could print that. So imagine it was basically a basketball with a baseball inside of it, and the two balls were completely separate. Nothing between them was integrated. They were completely separate. You could shake the outer ball and the inner ball and move, and they were nothing attached. And there's just no real way to get that accomplished today with traditional methods of manufacturing. So and that's one of the things is it's really getting people to think outside of the box and change their paradigm shift to saying, well, here's this really great idea, like here's this really great solution, but we can't quite do that. We can't quite design that. And that's kind of one of the things you have to break. It's a bad habit, if you will, because it's learned or it's taught in school, and you go to work, and especially when you're one of the older, more senior engineers, is you've never designed in this way before. You've never had the ability to think like this, and it's really trying to shift your paradigm and take advantage of the new technologies for maybe more efficient, more effective designs. So with design, they're looking at many different things. So the first one is complexity exploitation. Again, basically what this is sub-assembly reducing. So if you use, like I think I gave this example earlier in the podcast, but if you use traditional manufacturing, you could have 19 different parts that came together and made one assembly. Well, with this new processes of 3D printing, you can make that whole assembly in one fell swoop. So instead of making 19 different sub-assemblies in their own molds, you can do it all in one swoop with 3D printing. And that's really taking advantage of the complexity. The next one is doing 3D functionally graded materials. So these are materials with spatially varying composition or microstructure. They're all over us in nature. For example, trees. Trees are a great example of this. But man-made structures are typically pretty homogeneous. So in my field, concrete pillars, they're volumetrically homogeneous. The advantage is it's great for production. So again, traditional methods of the assembly line work, if you will, it was great for production. It's pretty easy to pour, concrete. Awesome. However, maybe not all of that concrete in every single area is needed. You could have more optimized for strength in certain areas where it's needed, more optimized for weight, material usage, etc. But with the traditional ways of manufacturing, it just wasn't feasible. That cost you would incur to optimize your homogeneous material for its intended purpose would not offset the effort you had to go through or the cost you had to go through to do that manufacturing. So they just said, it is what it is. We could change it, but the money or the economics don't work out to make it worth it. However, with 3D printing and the new design processes, that's a hard word to say, too many S's. There's improvements that can be made in strength, weight, and material usage. There's also multi-material integration. So you can this is called 4D, and I will have to make a separate episode for this. You can program different properties into various parts of a product's geometry. So one of the examples that I saw, and this is really interesting, is water pipes that know when to expand and contract for varying flows. So the flow of water in a city is not the same at every hour. It's typically higher, in the morning before rush hour when everyone's getting up, brushing their teeth, washing their face, taking a shower, cooking breakfast. It's pretty low throughout the day because everyone's at work. And then at the end of the day, again, it goes back up as people, shower again, cook dinner, and things of that nature. Whereas right now, pipes are rigid. A pipe is 18 inches, whether it's flowing full of water or there's not a single drop in it. Whereas with this you could possibly have pipes that expand and contract with the flows. That's something really interesting to look at. Another one is doing model-based inspection. So I'll touch a little bit on this. I'm definitely not an expert. So they reduce the ambiguities and create many opportunities for cost reductions and improvements in lean principles, which relates back to design, how it was designed versus how it was built. They've always been in pursuit of the paperless plane, not a paper airplane, a paperless plane. So whereas plane would be drawn on CAD software, 3D modeling software, the drawings would still be printed out on blueprints to be manufactured in the shop. And with 3D printing, you don't need blueprints. You just send the file to the 3D printer and it's printed. So it eliminates that paper, and which eliminates some air, if you will. Now, obviously, you can't 3D print a plane yet. Well, you could technically 3D print a plane. It'd be darn expensive. It wouldn't be economical, but from a possibility standpoint, it's true. I know at a recent 3D printing conference, they 3D printed a car body at the conference. And it wasn't really to say, look, it's really economical to 3D print this car body. It was more of like, look at what this technology can do kind of thing. It's more of a, whoa, like mind-blowing. I didn't realize it could do that. And the last thing with the design is product individualization and customization. Everybody loves when things are made for them. Is a tailor-made suit. Everybody loves the fit of a tailor-made suit. Once you buy one, you can never go back to the off-the-shelf suits. The same with first class. Once you fly first class or you fly private, you never want to fly commercial again because everything's very customized. It's very individualized to you. And brands are kind of moving away from mass production to this more personalization. It works well for the brand because you feel more connected with that brand, if you will, and you keep patronizing the brand over and over again because you feel a closer connection, a closer bond with them. For example, you would be much more likely to buy from Joe's Donuts if Joe is your best friend than to go to Krispy Kreme or something like that. It's more personal. It's more individualized. You feel a connection. Before, with traditional manufacturing, you weren't going to stop a whole assembly line process to do one thing for one customer. But with 3D printing, because each print is done in one at a time, you have that ability to make things more customized, more individualized, and now it's more cost effective for them to reach consumers on that more personal level, create that brand loyalty, which does too. I mean, it's a win-win for everybody. You get what you want exactly how you want it, kind of like BK, the Burger King, have it your way. And the brand gets you as a customer for life so long as they don't screw up that relationship. It's a win-win for everybody. So after the design swim lane, what do we get into? The next is the process. So we have a design down. Now we got to make sure the process is right to take care of it. So with this swim lane, what they're doing is they want to push technological advancements that will enable a faster, more accurate, and higher detail resolution with 3D printers and a larger build volume. So right now, there's basically with everything a pro and a con, or a trade-off. So the faster your print, the lower the resolution, and the poorer the quality, if you will. And it's the same idea with really anything. If you want something super fast, it's usually not a very high quality. For example, McDonald's. You can get a burger in probably under a minute. But if you wanted a nice steak in under a minute, it'd just be burnt. Like it's that idea. A nice, juicy steak takes time. You got to put on a lower heat. You got to slowly grill it. It's nice. It's juicy. It doesn't need any barbecue sauce, even though I love to put barbecue sauce on my steak. Whereas if you were just to cook that sucker at 1,000 degrees, it'd be done in snap of a finger, but it tastes terrible. It's the same idea. There's that trade-off that they have. If you want it fast, your resolution is sucky, but if you want your resolution to be good, it's not as fast. So obviously trying to decrease that trade-off or decrease that gap. And also build volume. Build volume's always been an issue. So biomedical and the aerospace industry are way ahead of the civil engineering industry. And part of it was because the material properties when 3D printing first came out were more plastic based, and unfortunately, plastic, it's just not really going to hold up in a structural situation. There's not going to be a plastic bridge. It's just not going to hold all of that weight. Also, and then again, the build volumes, they just weren't big enough. You just couldn't print things that would be large enough for civil engineering applications. Now that's becoming a little bit less of an issue, but nonetheless, it's still something that can be addressed and improved upon. So the other part of the process swim lane is targeting some critical technologies associated with the subsystems, at the machine level where there's process performance improvements are needed, where they're needed. It's similar to the machine tool flexibility manufacturing systems. And what I found on that was those systems basically can react to changes in production or react to changes in orders. And there's two subcategories, and the one that 3D printing is addressing is the machine flexibility, which covers the system's ability to change to produce new product types and the ability to change the order in which the operations are performed on a part. And that's kind of the same with 3D printing. You're able to adjust it to the need of the orders as they come in. So the main improvement focus areas that they're looking for are basically the metrics that they've set in the swim lane are build speed, accuracy, the detail capability, surface quality, and maximum part size, which we touched on in the first point, the accuracy, the resolution, and the build volume. And again, build volume, that's kind of an outlier, if you will. That's not really controlled by the speed or the accuracy, if you will. It is, in a sense. Obviously, a larger build is going to take a longer time, which relates back to build volume. But speed and resolution or accuracy and quality are really tied together, like the steak example. Whereas the part size, that's really just based on the printer build volume. And as the technology becomes better to print larger parts, that's kind of its own unique thing, whereas the other two are pretty much tied together or correlated, if you will. All right, so after we get through the design and the process, now we have to touch on the materials and the materials swim lane. So what material are we going to use to print our part from? So one of the things with this is, and this is something that's very near and dear to me because it's the current roadblock that I'm facing with civil engineering applications. So they're trying to build the body of knowledge for basically benchmarking additive manufacturing material property, characterizing the data, and eliminating the variability. So this is very interesting. So because because the technology is new, so there's no benchmark, there's no performance data, there's nothing. It's all new. And trying to create a standard of what to compare it against. So I know one of the issues is biomedical uses of the technology. They have the same hurdles I do because they put it in someone's body. You want that to perform. You don't want that to attack the body, as you sometimes hear with, when they do a heart transplant or a blood transplant or something like that, where the two DNAs don't match and your body attacks the other person's blood or organ that was put in you. So with biomedical engineering, they have a lot of qualifications that they have to go through, but how do you know what's enough qualifications? How do you know what tests to do, what you should do, what you shouldn't do, when is enough testing enough? So they've been working with the FDA, and there's actually a fellow here in Akron, Ohio. I listened to a short presentation given by him about all of the hoops, if you will, that he's gone through to qualify 3D printed parts for biomedical applications. And then the other thing is the variability. Right now, with 3D printing, it's tough to get the same part twice. If you print the same part on the same printer with the same material at the same speed and everything's the same, chances are higher than not that those two parts are going to be slightly different. So there's a degree of variability that just needs to get worked out. It's a new technology. It's a kink. So basically the metrics that America Makes is using for this area is to standardize feedstock materials. So when the technology first came out, everything was proprietary. Everything was patented. It was protected. So when all those patents were off, when in 20 years, 25 years, when they all were off, there was a flood of really similar materials that hit the market. And the reason because each 3D printing company needed to make materials for their printer. Let's say all of your materials are basically exactly like A36 steel, but you call yours something slightly different or tweak it just enough to get a patent filed on it, and then all your patents were off, and then all of a sudden 12 different materials that are basically, at the end of the day, A36 steel hit the market. There's no real standard feedstock material. Everyone kind of makes their own feedstock. And then benchmarking again. What's a benchmark? Where do we compare it to? Is this better? Is this worse? Then process property structure relationships, process window boundary definition, and post-processing guidelines and specifications. This is huge. One of the things that I didn't realize personally when getting into 3D printing, that there was sometimes post-processing that had to take place, where a lot of the ways it's portrayed in the media is you draw this file, you click print, and then 5 hours later you have your new whatever. Where there's actually sometimes there is some post-processing. You have to get rid of some support structure. You have to machine it, make it a little bit more aesthetically pleasing to the eye, give it some better finishing touches and something. So it's not just plug, print, and go. It's a little bit of post-processing guidelines, but those are kind of done on a as-needed basis or done on a kind of what's up to the owner. But there's no real standard yet. ASTM is a little bit behind the 8 ball when it comes to this. They aren't up to speed. They have a subcommittee, I believe the number is F42, that's addressing this, and I've talked to actually a member of that subcommittee at Cleveland State University, Case Western University, in regards to my graduate research project. So, lastly, we have the value chain swim lane. Here, what America Makes is trying to do is they want to enable step change improvements in end-to-end value chain cost and time to market for additive manufacturing produced products. The unique thing with additive manufacturing is you can do a lot quicker prototyping, testing, and all that stuff because it's simply a couple tweaks on a CAD model and you're good to go. You don't have to go get new tooling, or new dies, and things of that nature, or new molds to create a new product or a new prototype. You just have to change a couple lines, change this, change that, and reprint it, versus going through the whole extra steps just to get a prototype, not even the product. So they want to speed up the qualification certification methods, as well as looking at a more holistic view of integrating the technology from cradle to grave. Right now it's not used cradle to grave. It's really mostly used in the early design prototyping process. Hasn't made its way all the way through the value chain or the product life cycle. So they also want to look at material and product recyclability. Because the technology is new, most of the products or parts that have been 3D printed haven't had the ability yet to be quote-unquote trashed or thrown out like we do with Coke cans or water bottles. So we don't really know, can we recycle it, can we reuse it, can we melt it down and put it back into feedstock? That's something to look at. So this area has also been designed to help drive a priority focus on identifying advanced manufacturing enterprise opportunities for creating a single integrated digital thread to help identify workforce skill set needs and technology enablers, such as design aids and apps to improve productivity and highlight the need for new and novel rapid design and inspection technologies. So some of these unique technologies, one I've heard of is GrabCAD. It's an app that you basically can control your 3D printer from wherever you are. You see how they're going, see if one's messed up, if there's a problem, update prints so you can print when you're not even there, or say, all right, you finished printing print 1, go on to print 2. You don't have to be there. You can be out of the office. You can kind of know what's going on. It's kind of like the car commercials. Basically, all of them have it now where on your phone you can lock your car without being there, or check in on your car, or turn off the AC in your house, or turn off the lights in your house, that kind of thing. It's the same idea. And identifying the needs, because again, it's kind of with 3D printing right now, it's really an experiment. It's I push this button, what comes out the other end, what happens, and kind of adjusting from that, and it creates new needs. And basically it's like you get a hole in your boat and you plug this hole and you fix this problem and you address this need, and then over here another hole comes up and you have to do the whole process all over again. It's a learning experience, and that's what makes it fun. That's what's so addicting to it. That's why I like it, is because I really am learning all the time. Like, I've no experience with this. It's never been done before, and it's basically a giant sandbox of push this button and see what happens. So the metrics that they're using are related back to pretty much cost, processing cost, feedstock material cost, quality control cost, labor productivity cost, and energy efficiency cost. Lastly, we have the additive manufacturing genome swim lane. Now, this wasn't part of the other 4 main ones: the design, the process, the materials, and the drawing a blank, and I'm not going to edit it out because I am human and I make mistakes, the value chain swim lane. So with the additive manufacturing genome swim lane, they want to be able to, again, enable step change improvements in the time and cost required to design and develop and qualify the new materials for additive manufacturing. How do you want to do that? We just touched on that in the value chain. A lot of this is unknown. It's kind of experimenting. So some of the approaches that they're taking to it, all these, again, are new and novel. That's kind of going to be a repetitive word here on the podcast. They're going to look at computational methods. Some will be physics-based, some will be model-assisted to develop material property prediction tools to basically say, I want this material performance and kind of how to get there, if you will. What do I need to alloy or what do I need to create? Develop some common benchmark data sets to validate these computational predictions. And then again, material property characterizations that help break the cycle of developing design allowable for every new additive manufacturing material process and combination. Because we're going to have to do this a lot. We want to have something that's repeatable, and that can be done in the future again and again and again, because the technology is infinite. We're always going to be coming up with new materials or new processes, and we want to make sure that nothing bad is going to happen. So in my case, in civil engineering, we don't want your bridge to fall down on you. We don't want your roads to cave in on you. We don't want your buildings to fall down on you. In biomedical, if they put a 3D printed part in you, they don't want it to react with your body in the wrong way or kill you. So the metrics that they're going to look at for this are modular open simulation frameworks, access to open, transparent material property data, multi-scale data management and sharing, and efficient material property characterization methods. So I want to thank you for listening to the first episode of the Structural MD podcast. I know that was a lot of material. It probably was a little rough. It was definitely rough for me to record. I made a lot of mistakes, but it's the first one, so it's only going to get better from here. If you have any questions about the stuff that I touched on in this podcast, please feel free to reach out to me. My email will be in the show notes. I will repeat it right now, just in case you can write it down. But if you can't, it'll be in the show notes on the website. And again, the show notes are at structural-md.com/P001. My email is J as in John, A as in Apple, H as in Henry, 243 at zips.uakron.edu. More than happy to answer questions. More than happy to, we could maybe even bring your question onto a future podcast episode. Definitely from here, I want to start touching on some of the history of 3D printing, kind of where it came from and where it is today. And I want to touch on all of the different processes that 3D printing can be used. 3D printing is the big overarching thing. So a good analogy is sports. Sports are cool. Yay, sports, right? So sports is the big thing, and then there's baseball, basketball, football, soccer, golf, frisbee, whatever, cross country, track and field, all those different things. And again, it's the same with 3D printing. So there's 3D printing, the big overarching umbrella, and then there's FDM and fused deposition modeling, and there's SLA, stereolithography, and there's direct laser metal sintering, and selective laser sintering, and all these different technologies and processes to use for 3D printing. So I definitely want to touch on those in the future episodes. I know this was a lot about America Makes, and my apologies. I just wanted to kind of bring this to people's attention that there is something out there that exists. I know some of the things were a little bit over my head. I'm struggling to get in the door myself because I'm not a paying member. Some of the things are private. I can't get in. But I'll work it out, and I'll definitely keep you in tune. And I think something I'm going to do is maybe every 10th episode or so, 20th, 25th, I don't know, we'll see how it goes. Update you on the graduate research project, really the main reason or the main motivation behind starting this podcast. So with that, I want to thank you for listening. I wish you nothing but success and health, and I look forward to you on the next podcast. Catch you later.